This is a joystick, which works with light. Whenever the joystick is moved, its movements are captured by the LDR and LED setup. Let's see how? The concept is straightforward. There are two sensors placed 90 degrees apart. And there is an LED connected to the joystick. As the joystick moves, so do the light rays. Depending on the intensity of the light falling on the sensor, the position of the joystick can be determined. We will require one LED in series with a resistor. In a voltage divider configuration, two LDR sensors are connected with a resistor each. Now let's connect the components. We will take the LDR, which is connected in series with a resistor. This will be in a voltage divider configuration. It has 3 pins, plus 5 volts, ground and output. We will connect them respectively. The same steps can be repeated for the second sensor. Here we have an LED that is connected in series with a resistor to limit the flow of current. It has 2 pins, power and ground. We will insert these pins into the rails of the breadboard respectively. After inserting the pins, the LED lights up, indicating a good connection. And here we can see, inside the box, we have 2 LDR sensors, attached to the 2 holes on the 2 walls of a cardboard box. These sensors will detect the position of the joystick. This is what the whole setup looks like. Here we can see all the components connected with each other to make the joystick work. Let's assume that we have 2 LDRs and 1 LED. The LED is connected to the joystick, and its light rays move with the joystick. When the joystick is at its normal position, the light falling below is equidistant from both LDRs. So, both show medium resistance. When the light ray is near the LDRs, both LDRs shows high reading. When the light is farthest from both the LDRs, both LDRs shows low reading. When the joystick is moved to the top right, the light moves to bottom left, thus the left LDR shows more reading than the top LDR. When the joystick is moved to the bottom left, the light moves to the top right, thus the top LDR shows more reading than the left LDR. This is how we can detect the exact position of the joystick. Let's connect the Arduino Uno to the computer via USB cable and upload the code. After opening the plotter, we can see the graph of the 2 LDR in red and blue color. As we move the joystick, the intensity of the light falling on the sensor changes. So does the graph. The graph changes proportionally to the movements of the joystick. That's how we can get the exact position of the joystick, and use it in our other projects, or for any other applications. That's all for now. See you again with more robotic technologies. Robotics every day.